The archaeologist brushes the last layer of red silt from the stone. She stops, turns it over. The edge is thick, asymmetrical, scarred with dozens of resharpening marks in a pattern she's seen 100 times before, in textbooks, from France. But this isn't France. This is a mountainous cave in southwest China, and the tool-making style she's holding in her hands has never been found anywhere in East Asia. Not once. Not in a century of looking. According to everything we know about human evolution, this object shouldn't exist, but it does. And what it implies about who was living in China 55,000 years ago is forcing scientists to ask a question that could rewrite the entire story of our species. To understand how we got here, we need to go back to 2019. A team of researchers from the Chinese Academy of Sciences begins excavating a site called Longtan in Yunnan province. It sits on the southwestern edge of the Tibetan Plateau, a remote mountainous region where archaeology has barely scratched the surface. They dig 2 trenches into the hillside. The soil is reddish, silty clay, layers of sediment laid down over tens of thousands of years, each one a frozen snapshot of a world that no longer exists. What they expect to find is simple. For decades, the scientific consensus has been clear. East Asia during the Middle Stone Age was a technological backwater. While Neanderthals in Europe and early modern humans in Africa were innovating, building complex tools and adapting to ice ages, the populations in China were supposedly doing almost nothing, making basic stone flakes, staying stagnant. That was the story. It was wrong. Over 2 seasons of excavation, the team pulls 3,487 stone artifacts from the ground. Among them, 53 scrapers and 14 cores stop the researchers cold. These are not crude flakes. They are sophisticated, thick, asymmetrical, with broad, sharp-working edges that show clear signs of repeated use and resharpening in a very specific pattern. The team recognizes what they are looking at almost immediately. It is a tool-making system called Quina, named after Quina, a famous Neanderthal site in southwest France where these tools were first described in 1953. In Europe, Quina technology is so strongly associated with Neanderthals that archaeologists treat it as a kind of fingerprint, a signature. Find Quina tools, and you have found Neanderthals. But here is the problem. The Longtan site is over 7,000 kilometers from the nearest known Neanderthal habitat. No Neanderthal fossil has ever been recovered from East Asia. Not a tooth, not a fragment of bone. Therefore, one of 2 things must be true. Both of them shake the foundations of what we thought we knew. Either Neanderthals traveled thousands of kilometers farther east than anyone ever imagined, crossing mountain ranges and unknown terrain to reach China, or something else was living in these mountains. Something that independently invented one of the most advanced tool-making systems of the ancient world. And we have no idea what it was, and that was only the beginning. Because to understand why this discovery sent shockwaves through the field, you need to understand what Quina tools actually are and why they matter. Quina isn't just a shape, it's a system, a complete technological package. The toolmaker starts with a prepared core, a rock carefully shaped, so that when you strike it at exactly the right angle, it produces a large, thick flake. That flake is then modified into a scraper, a heavy-duty cutting tool with one sharp side, designed to work animal hides, slice meat, shave wood. The edges show layers of scalloped, resharpening marks, each one evidence that the user came back to this tool again and again. In Ice Age Europe, between 70,000 and 40,000 years ago, Neanderthals relied on these tools to survive some of the harshest conditions the planet has ever thrown at a human species. Temperatures were plummeting, resources were becoming scarce, herds of reindeer, giant deer, horses, and bison were migrating across open woodlands, and the only way to keep up was to travel light and carry tools that could do everything. Quina scrapers were that tool, versatile, durable, designed to be resharpened and recycled over a long period of use. They were, in effect, the multi-tool of the Ice Age, and they were built by hands that knew exactly what they were doing. Think about that for a moment. 55,000 years ago, someone stood in this river valley in southwest China, looked out over a landscape of open grassland and scattered forest, and made a decision. They picked up a stone. They shaped it with a precision that required knowledge passed down through generations. They created something designed to keep them alive in a world that was getting colder, harder, more unforgiving by the year. We don't know their name. We don't know their species. We don't even know what they looked like, but we know they were skilled. And until this discovery, we didn't know they existed at all. So the central question becomes, who made these tools? The research team, led by scientists from the Institute of Tibetan Plateau Research, used a technique called optically stimulated luminescence dating, a method that measures when sand grains were last exposed to sunlight, to pin the Longtan artifacts to between 60,000 and 50,000 years ago. This is the same window when Neanderthals were using identical tools in Europe. Meanwhile, pollen analysis from the site revealed something striking. The ancient environment at Longtan, cool, dry, open grassland, was remarkably similar to the landscapes where Neanderthals used Quina tools in France. Same climate, same ecological pressure, same technological response. But here is what does not add up. If Neanderthals brought this technology to China, there should be a trail, Quina sites stretching across Central Asia, through the mountain passes, across thousands of kilometers of terrain. There are none, not a single confirmed Quina assemblage between Western Europe and Southwest China. It is as if the technology simply appeared, fully formed, on the other side of the world. Therefore, the researchers proposed two competing explanations, and neither one is simple. The first possibility is that Neanderthals actually made it to China. We know they lived in the Altai Mountains of Siberia around 200,000 years ago, at a site called Denisova Cave. That is already farther east than many once believed possible. From there, could they, or populations they influenced, have pushed south and east into China? Perhaps they encountered another species along the way and passed on their toolmaking knowledge through direct contact. Skulls found in Zhuchang in central China already display some Neanderthal-like features. The study authors noted this could indicate that interactions occurred between Western and Eastern populations, exchanges we have never accounted for. But there's a second possibility, and it's equally compelling. Someone else figured it out on their own. A completely different species of ancient human facing the same brutal climate under the same survival pressure independently arrived at the same technological solution. Convergent evolution, but for culture. And this is where the story gets personal, because the most likely candidate for that someone else is one of the most mysterious groups of humans who ever lived. In 1980, a Tibetan monk was praying inside Baishia Karst Cave, a sacred site nestled against a towering cliff face at nearly 11,000 feet on the Tibetan plateau. Among the cave's rocky confines, he found a jawbone, two massive teeth still attached, clearly human, but not like any human alive today. He gave it to a holy man. The holy man gave it to scientists. For decades, no one could figure out what it was. It was not Homo erectus. It was not Homo sapiens. It had no chin. Its teeth were enormous. Then, in 2019, researchers extracted ancient proteins from one of those molars and matched them to a lineage identified only from fragments in a Siberian cave, the Denisovans. A third kind of human, neither us nor Neanderthal, who were once spread across vast stretches of Asia. That jawbone, the Xiahe mandible, was 160,000 years old. It proved the Denisovans had been surviving at extreme altitudes long before our species even arrived, and now the pieces start connecting. The Denisovans were the Neanderthals' sister species. They split from the same ancestor over 400,000 years ago. They shared a common technological foundation. They lived throughout Asia, including on the Tibetan plateau, not far from where these impossible tools were found in Yunnan. Could the Denisovans have made the Longtan tools? Study co-author David Del Piano, an archaeologist at the University of Ferrara, believes it is plausible. He says that starting from a base of knowledge, a technological foundation common to European Neanderthals, local groups might have reinvented this tool-making tradition because it was well-suited to their ecological conditions. But Ben Marwick, co-author from the University of Washington, raises the stakes even higher. He asks, could we find a Denisovan? If researchers can find the human remains associated with this period, they might find something surprising. Maybe even a new human ancestor that we do not know about yet. A new human ancestor, an entirely unknown species. And the only clue to their existence is a set of stone tools that, according to every model we had, should not be where they are. But the researchers have not found a single bone at Longtan, no DNA, no fossils. Whoever made these tools left only the tools themselves and then vanished. The answer was not at Longtan, but it might be waiting in the next valley over. And to see why, you have to step back and look at the bigger picture, at what this discovery is doing to the entire field of human origins. Here is what we knew before. The Middle Stone Age, roughly 300,000 to 40,000 years ago, was a time of extraordinary change in Europe and Africa. Neanderthals were building complex societies. Modern humans were developing language, art, symbolic thought. But East Asia was treated as an afterthought, a vast region where nothing much happened for hundreds of thousands of years. That narrative is now collapsing. This is a big upset to the way we think about that part of the world in that period of time, Marwick said. And he's not alone. Ben Utting, a researcher at the Smithsonian, called it part of an ever-growing list of discoveries that expose Eastern and Southeastern Asia as the next frontier in human origins research. While archaeologists long considered Eastern and Southeastern Asia to be cultural backwaters, he said, these discoveries are helping to reverse that narrative. The Longtan find doesn't stand alone either. Levallois tools, another advanced stone shaping method once thought rare in East Asia, were recently discovered at Guanyandong Cave in south-central China. Together, these sites paint a picture of a region that was far more technologically dynamic than anyone gave it credit for. And just months after the Longtan study was published, a separate team announced something that deepens the mystery even further. A jawbone dredged from the seafloor near Taiwan, discovered by a fishing trawler and passed through an antique shop before reaching scientists, was confirmed through ancient protein analysis as Denisovan. It was the first direct fossil evidence of Denisovans that far south and east. Their range was not limited to cold Siberian caves and Tibetan mountaintops. They were everywhere, from freezing altitudes to subtropical coastlines. Remember, we carry their DNA. Modern Tibetans inherited a gene from Denisovans that allows them to breathe in the thin air of the highest plateau on Earth. Populations across East Asia, Southeast Asia, Australia, and Melanesia carry traces of Denisovan genetics. We interbred with them, we lived alongside them, and yet until very recently, almost everything we knew about them came from a handful of bone fragments pulled from a single cave in Siberia. Therefore, the Longtan discovery isn't just about stone tools. It's about recognizing that for hundreds of thousands of years, Asia was home to a tapestry of human species. Denisovans, possibly Neanderthals, maybe Homo longi, the large-brained populations of Zhuchang, and perhaps groups we have not even named yet, all living, adapting, and innovating in ways that the fossil record has barely begun to reveal. But the researchers saved the most tantalizing detail for the end of their study. Lead author Li Hao revealed that since the initial excavation, the team has identified more than 30 additional sites containing Quina artifacts, all in the same river valley surrounding Longtan. 30 sites in one valley. This was not an isolated incident. This was not one wandering group passing through. Whoever made these tools lived here, thrived here, built a culture here. And they did it using a technology that, until this discovery, we attributed exclusively to Neanderthals an entire continent away. The excavations continue. Deeper layers at Longtan and the surrounding sites may hold the answer to whether this technology was invented locally, meaning someone in China figured it out independently, or whether it arrived from outside, carried along routes we have never mapped, by people we have never identified. And beneath all of it, the deepest question remains unanswered. If we find human remains in those layers, what species will they belong to? It could be Denisovan. It could be Neanderthal. It could be something entirely new, a human ancestor that walked these mountains 55,000 years ago, survived an ice age with tools they built with their own hands, and then disappeared so completely that until a team of archaeologists dug 2 trenches into a hillside in Yunnan, no one on Earth knew they had ever existed. The next chamber has not been opened yet, but when it is, the map of human origins may have to be redrawn from scratch.